One of the things I'm going to ask you to do this week is to take a look at the problem of slip versus tip. Okay, we've already talked about this in one of the other assignments, but one of the things we know is that if I raise the angle of this inclined plane, eventually this will either tip or slip, and we can make predictions mathematically and also through our personal experience about which is going to happen first. And so I think if you look at the geometry of this, you can make the guess that this is probably going to slip first. And if I keep going, I raise this, yes indeed, it starts to move, it's slipping. Okay, and so what's going on is that as I raise this inclined plane angle, the weight, the weight is pulling straight down due to gravity, but it gives you an x component of force moving this way, and there's a friction force that's proportional to the normal force. Remember, it's mu times n, and as long as the normal force can be strong enough to oppose the weight, the block's not going to move. But eventually the maximum friction force is mu times the normal force. And once you exceed that maximum, once the weight is heavy enough, it will pull the block down the inclined plane. Okay, and we talked about you can estimate what the coefficient of friction is based on this. And so you can take a look at this angle. And so I'm going to do that. I'm going to try to do that and hold all these together with a phone. Okay, so this is the level app on a phone. Okay, and so we zero that out and we start to raise this. And my idea here is to try to find what angle this thing starts to slip. So I see it around 29 degrees, it starts to slip. And so from that, we can calculate the coefficient of friction. Tangent of theta gives you mu s. Okay, so the question is, what about tipping? What's the mathematics on tipping? Well, it turns out that when this block is flat on the plane, there's a normal force that operates along the line of the center of gravity. But as you start to tip this up, the pressure on the normal force is not equally distributed. And so the effective normal force starts to move this way along the block. So as at zero, the normal force has this line of action. As I raise this a little bit, it moves over a little bit. And as I get closer and closer to the tip, the effective normal force is getting closer and closer to this edge. Okay? So if you think about sum of moments, the weight force is moving down this way, and it's creating a moment that's moving counterclockwise, and the normal force that's acting up is counteracting that moment, so the moments are zero. What happens though, when you get to the tipping point, the corner of the block goes up, and there's no place for the normal force to be exerted. The normal force is suddenly gone. All right, so when that's gone, there's no opposition forces. The sum of forces, or the sum of moments, is no longer zero, and so the object starts to tip over. Okay, so at that tipping point, as long as the center of gravity is on the correct side to generate a clockwise moment force, there will be a normal force acting to counteract that. All right, but what happens is, what if we tip this over where the center of gravity moves this way? Okay, in that case, there's no place for the normal force to react, and the body's going to tip over. All right, so I can see that I'm going to hold this to keep it from slipping. Okay, but as soon as we're watching this line here, as soon as this line gets past 90 degrees, okay, when it gets past 90 degrees, it's close to 90, it tips over at that point. Okay, so that's the idea of what's happening. When I talk about this getting at 90 degrees, this angle is alpha. If I add theta, alpha plus theta, if alpha plus theta is greater than 90 degrees, the block's going to tip over. Okay, so that's the mathematics of that. And from the geometry of the shape, you can easily calculate alpha because we know the center of gravity on a rectangular block. And so you can just use some trig to find what that angle alpha would be. Okay, so that's what you need to know to work on this lab assignment that I'm going to give you this week.